Salutare tuturor, bine ați venit la un nou episod cu o lecție din FS Academy Interceptor. După cum v-am spus, în opinia mea, cel mai bun training care există în acest moment în Microsoft Flight Simulator 2024. Episodul de azi are ca obiect Glass Cockpit-ul. Haideți să vedem cum merge.
Start, loading 11. Ready to fly.
Technology in avionics moves slowly but relentlessly. One of the most impactful changes to be seen in the world of light aircraft is the integration of the familiar six-pack of instruments into a single electronic display. Forged on the flight decks of jetliners, the glass cockpit provides the IFR pilot with a new, clearer presentation of all the critical flight path information. The example we see here is the Garmin G1000, now commonplace in any modern training aeroplane. All of the main flying instruments remain in view, with the attitude at centre stage, making up the entire background to the primary flight display, or PFD. Again, we have the familiar blue sky and brown ground, but notice how the horizon stretches the full width of the screen. The larger, clearer display of attitude reinforces its importance in our scan, plus making attitude changes easier to distinguish, given their amplified size. Along the top is the bank scale, showing the familiar 10, 20, 30, 45 and 60 degree bank marks. At the base of the bank index pointer, we have a side slip indicator. If the indicator moves to the right of centre, add some extra right rudder pressure, and vice versa for left rudder. The heading indicator has also received a significant update. Still in its conventional home below the attitude, this new digital display shows exact heading degrees, instantly improving your precision. Add to this the new solid-state magnetometer, which detects our magnetic heading, and we do away with the limitations of a gyroscope-based heading indication. Significant further enhancements are also to be found, such as the embedded bearing needles. These can be set to show VOR and NDB needles directly on the heading indicator, so no longer must we mentally superimpose a needle. With new capabilities comes a new name, the Horizontal Situation Indicator, HSI. To the left of centre we see our airspeed indication, now presented as a speed tape. To the right of our attitude we see the altimeter right where we expect it, but now coupled with the VSI further to the right. So we have seen the new face of 5 out of our 6 main instruments. What about the turn coordinator? Look to the top of the HSI. Either side of the heading window, where we see our heading, there is a small scale to the left and right. During a turn, a magenta indicator will appear in the direction of turn. Once a rate 1 turn rate is achieved, we will reach the full scale position. By now you will see that all of the familiar indications remain, but with a clearer, more precise presentation. To ease the task of maintaining heading at altitude, we can now utilize the concept of bugs. A bug is a marker that we place on a digital instrument, such as a heading or altitude target. Having a target bugged makes it more immediately identifiable. Bugs are set with physical controls, providing easy access in the busy cockpit environment. Use the heading knob to set a heading bug at 083 degrees.
Să fixăm heading-ul pe capătul magnetic 080.
Heading knob.
083. Oh.
See how a blue bug now sits atop our target on the HSI. We are less likely to miss this during a complex manoeuvre, improving accuracy further. We can see our selected heading to the top left of the HSI, displayed in blue. The altitude knob has 2 controls, the large outer knob for thousands of feet and small inner knob for hundreds. Use the knobs to set an altitude bug of 5,000 feet.
Să fixăm altitudinea la 5000 de picioare.
The
Altitude.
PFD contains more than just our conventional six-pack. Look to the top left of the PFD and see our nav radios displayed. Here we can tune our nav1 and nav2 radios to a desired nav aid. The conventional standby and active concept remains, switched with the swap button. An inner and outer knob is also present. The outer large knob sets the large numbers of our frequency, the megahertz, whilst the small knob sets the smaller digits, the kilohertz. Tune Jersey VOR into the nav1 standby window, frequency 112.2.
112,20, 112 MHz și 20 de kHz.
And press the swap key to make it active.
Și acum o activăm.
Now that we have tuned, our next step is to identify, as always. Rather than listening for the Morse code identifier, the G1000 is already doing this for us automatically. Notice the Juliet Sierra Yankee identifier displayed beside the active nav1 frequency. The Jersey VOR is now tuned and identified, ready to be displayed on our HSI. At the base of the PFD, see the CDI button. This allows us to toggle between the various display modes available for our CDI, which is now built into our HSI. By pressing this, we now have our CDI set to display nav1. To select a course to fly, we use the course knob, located to the right of the PFD. Set a course of 004.
Setăm cursul
Course
la
setting.
004.
See how our CDI operates in the usual way, displaying our deviation from the selected course, but now with a green bar. It currently shows a fly right indication. Deviation dots on the CDI show up to 10 degrees of deviation to either side of the centre. One dot represents 5 degrees. The to from indicator is shown as a green arrow at the end of the CDI bar. It currently shows 2. Our HSI is much more intuitive than the OBS and heading indicator, as we can display what we need right there on the dial. Now look again to the bottom of the PFD and see the PFD Options button to the bottom left. Pressing this opens a menu for changing the displays on our PFD, including the HSI. Open the PFD Options menu and see the options for bearing needles. Click on bearing 1 until it displays nav1. We now have a blue bearing needle that points directly to the VOR set in our nav1 radio. We can use this bearing needle in many ways to make IFR navigation more simple. This includes the option to set our CDI to a desired course, but still keep the ability to navigate to the VOR using the bearing needle. For example, if we were to intercept the radial 004 from the VOR, we could fly towards the beacon with the bearing needle, with our outbound course 004 already set on the CDI, ready for interception. But how do we know our distance from the station? We have another new benefit, the DME. Distance Measuring Equipment, DME, transmits a signal that is interpreted by our avionics as a distance. When we selected bearing 1 to nav1, a small window appeared to the left of the HSI. Within this window we see our DME. We are currently 6.3 miles from the DME station, which is located at the Jersey VOR. One thing to be mindful of, however, our DME displays our distance from the beacon via line of sight. This means that once directly overhead the beacon, we would not get a 0 miles indication, but it would display our height above it in nautical miles. This is known as slant range. For example, 1 nautical mile is approximately 6,000 feet. If we flew overhead the DME at 3,000 feet, we can expect a 0.5 nautical mile indication. Instrument procedures are built to take this factor into account. It also becomes less and less relevant with lower altitudes and greater distances, but is something that you should be aware of when passing overhead a DME station. Let's now turn our attention to handling NDBs on this equipment. Along the bottom of the PFD, press back to leave the PFD options page. Then press the ADF DME button. This opens up the ADF tuning window. Unlike our old ADF radio, we can now have an active and standby frequency set, like our nav radios. Use the FMS knob at the bottom right of the PFD to tune the standby ADF to Jersey NDB, frequency 329. The large knob moves the cursor and the small knob changes the digits. There is space for 5 digits with the decimal, so set 0329.0, pressing enter to set.
FMS knob. FMS joist F
Doamne, cât de greu se vede. 3,
FM
2,
F
9.
FMS knob.
Enter.
Now press the enter key to make 329 the active ADF frequency. The ADF is now tuned, but must be identified. To the right of our PFD, we have our audio panel. Within the white box in the centre of this panel, we have our ident audio controls. Turn on the ADF ident.
AD
A light appears above the ADF button when the ident is enabled. You can turn off the ADF ident now if you wish. Go back to the PFD options menu and
Yoke
set the
visibility.
bearing to needle to display ADF.
Să punem ADF-ul pe bearing 2. Nav, ADF.
We now have a bearing needle pointing to the NDB. Notice how the bearing 1 needle is thin and the bearing 2 needle is thick to differentiate them.
yoke
Now look across to the right side of the cockpit to our other main display, the MFD. The multifunction display, MFD, displays our engine parameters down the left-hand side. We are mostly interested in the RPM indication at the top
Joystick.
left of the MFD. The moving map display on the MFD can be useful for orientation and for displaying airspace, airports and other navigational features. But we will not be utilising most of these features as part of this course, as we want to instill the fundamental skills of IFR flight, so we will make only minimal use of the MFD. We have covered a lot in this introduction to the G1000. Once we get airborne, it will start to feel more intuitive, and I expect it won't take long to appreciate how these more advanced avionics help you to fly IFR. We will now move on and perform an instrument departure.
Interesant, foarte interesant. Chiar dacă sunt chestiuni de bază, cred că merită structurate așa cum arată cursul acesta.
post training reward.